All right, guys. So today we're going to do another lesson that's almost exactly like yesterday's. The only difference is today we're talking about linear transformations, not quadratic. Now remember yesterday to do the quadratics, we had to know the parent function. The parent function of the quadratic was y equals x squared. Well, we need to use the parent function for the linear, which is f of x equals, remember that's the same as saying y equals, well f of x equals x. This is our parent function. This is the one we're going to plot a bunch of times today. Let's look at it in our calculator real quick. You may know what it looks like. I'm going to y equals, I'm going to hit x, I'm going to hit graph. So it looks like my graph goes through the center, or the origin, 0, 0. And if you notice, it goes up 1 and over 1 every time. Remember, this really has a slope of 1, which is a rise over 1, or rise over run of 1 over 1. So I go up 1, over 1. And you can do that a couple of times to get a good line. Then you just sketch it in. So that's the one we're going to do every time. Remember that line is, the slope is 1, so that's rise over run, and that's how we can find those other points. Now, we're going to go ahead and do kind of what we did yesterday. We're going to talk about what happens when I change that. The first thing we're going to do is add and subtract things to my equation. Well, we should know what happens here. We're going to check one of them and make sure we know. It says f of x equals x, g of x is f of x plus 1. Well, guys, if f of x is equal to x, I change it to x, and I add 1. Now, we can probably guess what's going to happen here. Yesterday, when we added something outside the parentheses, it shifted up or down. Well, this one looks like it might shift up 1. So I'm going to check in my calculator real quick. Let's just make sure it's the same as yesterday. I'm going to keep y1 is x. I'm going to put x plus 1 in y2. And that's exactly what it looks like happened, is it shifted up 1. So we're going to move our point at the origin here up 1 space. But we need our other points. Remember, the slope is still 1, so I go up 1 over 1, up 1 over 1. So there is my transformed line. So just like yesterday, we add something to the outside, we get a vertical shift. Let's look at the next one. You can probably imagine what's going to happen here. I have f of x minus 2, so that's going to be x minus 2. Now, I'm pretty sure we don't need to look at our calculator for this. I think that means we're going to shift down 2 units. So I'm going to go from the origin and go down 2 and plot my new point. Now, the slope is still 1, so I'm going to go up 1 over 1, up 1 over 1. There's my third transformed line. So it looks like everything worked exactly how it worked yesterday. I'm going to check that real quick. I'm going to put that x minus 2. Let's make sure it shifted down, and yes, we were correct. So we can pretty much write the same things we wrote yesterday. What did the plus 1 do to the graph? It was a shift up 1. And then what happened when we did negative 2 to the graph? It was a shift down 2. So it's exactly the same as yesterday. It's even easier, though, because it's just straight lines. All right, guys, let's go on and see what happens when we do stuff inside the parentheses. So you should remember from yesterday, the outside was vertical, the inside was horizontal. So let's go ahead and look at the next one. We're still using our parent function f of x. Oops, let me see if I can make this work. There we go. We're still using our parent function f of x equals x. So that's the first thing I'm going to do. I'm going to plot a point at the origin. I'm going to go over 1, up 1 a couple of times. I'm going to sketch my line. Not perfect, but it's a good sketch. Now they're asking us to do things inside the parentheses. It's not f of x plus 3, it's f of, in parentheses, x plus 3. But the good thing about these is it doesn't really matter. Basically, if I have x plus 3 in parentheses or x plus 3 outside, it's going to do the same thing. Now, we should be looking for a horizontal stretch or a horizontal shift because we're inside parentheses. So let's put that one on our calculator. So I already have x into y1. I'm going to go down to y2. I'm going to change it to, if it's in parentheses, it's the same as without. Let's see what happened. Well, now it looks like, let me get my marker here, we shifted 1, 2, 3 units to the left. So I'm going to come over to my graph here. I'm going to shift my origin over 1, 2, 3 points. The slope is the same, so up 1 over 1. Up 1 over 1. So there is my transformed function. Let's go ahead and look at the other one. It's x minus 4. Well, that's going to give me either parentheses x minus 4 or x minus 4. It doesn't really make any difference. But I can imagine that we're going to go in the right direction this time because it's opposite over 4 units. 1, 2, 3, 4. And then up 1 over 1 to complete our line. Now I want to check that and make sure I'm right. So let's see, y equals, it's x minus 4. We're hoping it shifted right 4, and it looks like it did. So let's go ahead and write on here. When we added 3 inside the parentheses, it went left 3. So it was a shift left 3. When it was at negative 4, it was a shift right 3. Or, I'm sorry, right 4. So it's the same thing as we did yesterday, guys. Remember, when it's inside the parentheses, we're thinking about horizontal. When it's outside the parentheses, like the first one was, we're thinking about vertical. So those are both pretty easy. Let's go ahead and look at what happens when we do negatives. Yeah, that worked. Sometimes that magic erase works, sometimes it doesn't. All right, so I'm going to go down to number 3. It says f of x equals x. I think I'm missing a grid here. I'm just going to use the one above it. I think you have one on your notes, so you should be good. If you don't, you can just kind of sketch it in. So I've got x, y. I still need to plot my parent function, y equals x. So I'm just going to give it one of those, over 1, up 1. There's our parent function. Sorry, I don't know where that went. I don't think it's on your notes either. But anyway, so you can sketch that in there. This one's pretty easy. Now, this is outside, so we should be thinking vertical, okay? That negative is outside our parentheses, so we want to think up and down. Well, to do that, we just put a negative in front of our x. So let's go ahead and look at that one in the calculator. I'm not really sure. Yesterday we had a reflection. Let's see what happens today. I'm going to leave x in y1. I'm going to clear out y2 and put negative x, not minus x, negative x. And if I look at it, it was another reflection. It kind of shifted it in the other direction. So I was still at the origin, but now I went the opposite direction. My slope would be negative 1, which is the same as negative 1 over 1, and that's your rise over your run. So if you want to think of it that way. So it says, what did negative do to the graph? Well, the same thing it did yesterday. It reflected over the x-axis. Reflected over the x-axis. All right, so those are exactly like yesterday. You might want to pay attention to 3 because, I mean, that looks a little different. It's kind of hard to see that it reflected, but that shouldn't be a big deal. So let's go ahead and go to the next page. Okay, well, there's the rest of it. I guess it's on the next page. Sorry about that. We'll go ahead and go down to number 4. This time, it's the same thing. We still need to graph our parent function. So I'm going to put my point at the origin and go over 1, up 1. I'm going to sketch my line. Now, it's doing something different. G of x doesn't have the negative outside the parentheses. It's inside the parentheses. But luckily for us, it's not going to change a whole lot because all we really have to do is just like last one. It's a negative, and even when we put x in parentheses, or the negative in the parentheses, it's going to be the same thing. It's going to be negative x again. So I don't even need to put that in my calculator because it's already there. It's going to be still at the origin, but its slope is going to take it in the opposite direction. So when we did this one, it was the same thing as the last one, but remember, we're inside the parentheses, so we want to be thinking horizontal. So it is a reflection, but it's not over the x-axis, it's over the y-axis. So there you go. So those ended up pretty much being the same thing, which is what the next question asks. If f of x equals x, what's the difference between negative f of x and f of negative x? In this case, there is no difference. Now, there are cases if it was moved around where they would be maybe a little bit different, but basically they're both negative x, so that's what we're going to get is negative x. All right, guys, so that one was not bad. We've done adding and subtracting inside and outside the parentheses. We've seen we had horizontal shifts when it was inside the parentheses. We've had vertical shifts when it's outside the parentheses. Let's see what happens when we multiply. So just like yesterday, number 5 says, graph f of x equals x. Okay, so we need our parent function. Got to point at the origin, over 1, up 1. Go ahead and sketch it in. Now, we're multiplying outside the parentheses, so we should be thinking about vertical shifts because we're outside the parentheses. Well, the first one says we're multiplying 2 by our f of x, so I could say that's 2 times x, but that's still just 2x. Either way, it doesn't change. Now, you should be able to look at that and realize what the change is. Our parent function's y equals x. Our new function is y equals 2x. The slope is what has changed. So instead of being 1 over 1 for our rise over run, it's 2 over 1 for the rise over run. So let's see what that makes our graph look like. So I'm going to go and get rid of the negative x and y2, and I'm going to put in 2x. Now if I look, it looks like it got steeper. That's because the slope got bigger. So when we graph it, we still are at the origin, but instead of going over 1 up 1, we're going over 1 up 2. Over 1 up 2. So what we got here, it looks like it just tilted, but really it's kind of like yesterday. Remember when we had this yesterday, it was a vertical stretch? That's really what's happened. Someone's grabbing our original graph and stretching it vertically. So what did 2 do to the graph? It was a vertical stretch. But you might also call that steeper. Okay, think about the parabolas yesterday. If we were sliding down the curves on the inside in the original, then sliding down the curves of the 1 times 2, it would be a lot steeper as well. So if that makes it get steeper, I wonder what happens to 1/2. So I'm going to take 1/2 times x and see what happens. Now you can see your slope this time. Slope is 1 over 2. Rise is 1, run is 2. So let's see what that looks like in our calculator. I'm going to get rid of my 2x. I'm going to put in 1 over 2x. Whoops, that's 4 over 2. 1 over 2x. And that's exactly what happened. It got steeper. Now, I was still at the origin when I started, but instead of going over 1 up 1, I'm going to go over 2 up 1. Over 2 up 1. And there's my next one. Now, we're still thinking vertical. A stretch made it steeper. So this one is still a stretch, but it's not a stretch, I'm sorry, it's a compression. So this is a vertical compression. What we could also say is that it makes it flatter. But guys, you know a lot about slope, and you should be able to see what happens when you when you change the slope. It's the rise over run that's changing. All right, let's go ahead and go to the next page. Now here's our last one, just like yesterday. And you're going to see some similarities to what we just did, actually. But remember, we're inside the parentheses now, so we're going to refer to it as horizontal, okay? So the first thing we need to do, again, is sketch our parent function. Plot a point at the origin, over 1, up 1. We can sketch our line. Now it's asking us to do stuff inside the parentheses, but lucky for us, just like when we did the adding and subtracting, it doesn't change a whole lot. So it's f of 2x, so that means I'm going to replace x with 2x and end up with just 2x in parentheses or just 2x. It's the same thing as we did last time. So the slope changed. Instead of 1 over 1, it's 2 over 1. So I go over 1 up 2. I have a point at the origin as well, over 1 up 2. So if I look at that one, it looks like it almost did the same thing that the last one did. So it says, what did the 2 do to the graph? Well, it wasn't a vertical stretch, it was a horizontal compression. Remember, it's always opposite when it's inside the parentheses, but you could again call that steeper. But you should know when you're multiplying by a number bigger than 1 that it's going to change your slope and it's going to get steeper. Now 1/2, it's pretty much going to be the same thing as the last one as well. We could put the 1/2 x in parentheses, but that's the same as 1/2 x. So again, all that changed is our slope. So I'm still going to have my point at my origin, but instead of going over 1 up 1, I'm going to go over 2 up 1. Over 2 up 1. Now, when that was outside the parentheses, we called it a vertical compression, but this is inside, so it's not a vertical, it's horizontal. And it's not a compression, it's a stretch. Like someone's off to the right pulling our original function. But you could also say that that's flatter. So just like yesterday, they're kind of opposite of what we did when it was outside the parentheses. But again, you should remember, something less than 1 but greater than 0 is going to make it flatter. Anything bigger than 1 is going to make it steeper. Now it asks us again, if f of x equals x squared, what's the difference between f of 2x and 2f of x? But just like that last one, there is no difference. So in this case, there is no difference. Oops. They both ended up giving us in the end y equals 2x. So that didn't change. So guys, this one's a lot easier. You only have to remember one set of things and you have a lot more. Let's go look at a couple of questions real quick. Let me erase all this if I can. Man, that's amazing. Sometimes that quick erase works, sometimes it doesn't. All right. So we got the same kind of questions we had yesterday. What kind of transformation occurs when the number is outside of the parentheses? Remember, guys, that is vertical. Okay, when you're talking about outside the parentheses, you're talking about a vertical transformation. If we're inside the parentheses, that's the opposite, horizontal. And by the way, guys, you can abbreviate horizontal with H or H-O-R-I-Z, something like that if you don't want to write that 100 times. All right, guys, so this is basically a lot like the stuff we did yesterday now. We have some examples. It says, describe the following transformations on the function g of x if our original function is the parent function. So we're not going to do all these. I think you'll see it's pretty easy. But really, if you just look back at your notes, guys, these are almost a joke. So the first one, I have f of x plus 2. Well, guys, that's inside the parentheses. So automatically know that is a horizontal shift. I'm just going to write H-O-R-I-Z. And since it's plus 2, remember it's like opposite direction. Since it's inside, that's going to be horizontally left 2. But really, guys, if you just wrote left 2, I understand what you're talking about. So the next one's almost exactly the same. I want you to try it out real quick. If we pause the video if you need to. Well, now it's almost the same thing as the last one. Instead of plus 2, it's minus 1. So it's still horizontal, but instead of moving left, it's going to move right 1. So look back at your notes, guys. I think you can finish the rest. Obviously, we have 2 outside the parentheses. You've seen that exact one before. Let's go to the next page. It's more of the same, guys. I mean, some of these are exactly what we did. We have this one right here. We've got these 2. This one's almost exactly like one. So most of those are the same things. You just have to go back and regurgitate what we said, okay? Let's look at these next ones. These are a little bit tougher because we actually have to write equations, but they're really not that bad if you'll just look back at your notes. So the first one, we're messing with our parent function, guys. So we're always starting with f of x equals x, and we're going to change it how they say. So the first one says shift left 4 units. Well, guys, left implies horizontal, which implies inside parentheses, which really doesn't matter too much on this one. So I'm going to have y equals, or f of x equals, and I'm going to take x, and if I put it in parentheses, because it's got to be horizontal, go left 4, it's opposite, so I'm going to put plus 4. But guys, that's the same thing. If you'll notice, and if you look back at some of the examples, even when we're looking like we're shifting left to right, you could actually be shifting up and down and vice versa. The next one, a vertical stretch by a factor of 5. Well, it's a vertical stretch, so it's outside parentheses, so I'm going to put the 5, then I'm going to put my parent function. You could put it in parentheses, or you could take it out. 5 times x is 5x. So guys, I think these should be okay. Look at your notes, finish that up. If you have any questions, feel free to let me know. Tomorrow we're going to talk about some of the other, we're going to talk about putting transformations together, like more than one at once. And we do have the quiz, so make sure and bring your notes. Good luck, guys.